All right. A massive hello to all the grade 11 students at Shrewsbury International. I know you've got your eyes on the prize, that A star in your 2026 IGCSE exams. Well, you've come to the right place, because today we are building the exact blueprint to get you there. Let's jump right in.
So, this is the big question, isn't it? How do you go from a tricky problem to a flawless program? Here's a hint. It's way more than just banging out code. It's about a way of thinking, a process, and it's a skill that IGCSE examiners are absolutely looking for. So, this is your definitive guide.
Here's our game plan. Think of this as our roadmap to success. We're going to walk through the entire journey, from a blank slate to a fully working program. Each part builds on the one before it, giving you a rock-solid framework to handle anything the exam throws at you.
First up, we're talking about the Program Development Lifecycle, or PDLC for short. Honestly, you can think of this as the secret sauce. It's the foundational blueprint that every single successful developer uses, whether they're making a simple app or a massive piece of software. If you master this, you're already thinking like a pro.
And here are the 5 core stages. It's a lot like following a recipe, really. You don't just throw ingredients in a bowl and hope for a cake, right? No. First, you read the recipe to understand it. That's your analysis. Then you get your ingredients ready and measured. That's the design. Then you actually do the mixing and baking. That's coding. You have a little taste to make sure it's perfect. That's testing. And finally, you serve it up. That's your launch. Get this order right, and everything else falls into place.
So let's dive into step 1, analysis. This might just be the most important stage of all. This is where you do the heavy lifting with your brain before your fingers even touch the keyboard. It's all about deeply understanding the problem and boiling it down to what really matters.
And we do this with 2 killer techniques. On the left, you see decomposition. That's just a fancy word for breaking a huge, scary problem into smaller, bite-sized pieces. And on the right, abstraction. This is where you filter out all the noise and ignore the details that don't matter so you can focus only on what's essential. One breaks it down, the other zeroes in.
Okay, now we're at the design phase. And for me, this is where the battle is won or lost. A great design, a solid plan for your program's logic, makes the coding part a breeze. A bad plan? Well, that's just a recipe for a nightmare.
And your number 1 tool for designing your logic is the flowchart. IGCSE examiners love to see these because they are a super clear visual map of your thinking. It proves you know exactly how data is going to move and what decisions your program will make, all before you've written a single line of actual code.
Let's break down the basic shapes you'll be using all the time. The rounded one, the terminal, is always your start and stop. Easy. The parallelogram is for any kind of input or output, like a user typing in their grade. And the diamond? That's your decision block. This is where the if this happens, do that logic lives.
And here are the other 2 heavy hitters. A plain old rectangle is for a process. That means any calculation, like adding 1 to a counter. The rectangle with the extra lines on the side, that's a subprogram. This is awesome for calling chunks of code you use over and over, which keeps your main flowchart looking clean and simple.
Your other essential design tool is pseudocode. I absolutely love pseudocode because it's the perfect middle step. It's structured like real code, but you write it in a simplified, human-readable way. It lets you map out all your logic without getting totally bogged down and getting every single comma and semicolon perfect. It's the ultimate rough draft.
The most basic thing you'll do in pseudocode is assignment. See that little arrow? That just means take the thing on the right, in this case the name Sam, and store it in the box or variable on the left called name. That's it. Every program, no matter how complex, is built on this simple idea of storing information.
So, here's what makes a program feel, well, smart. Its ability to make choices. The if then else structure is your best friend here. It's simple. If some condition is true, then the program does one thing. Else, if it's not true, it does something different. This is how you create branching paths in your logic.
But what if you have, 5 different choices? You could write a messy chain of if statements, but that gets complicated fast. A much cleaner, much more elegant solution is the case statement. It looks at one variable and then jumps to the right block of code. It's way more efficient and easier to read. And trust me, examiners notice that kind of smart thinking.
All right, let's talk about loops, because this is where people get tripped up. Just remember this one key difference. A repeat until loop will always run at least one time, because it checks the condition at the end. A while loop, on the other hand, checks the condition right at the start. So if the condition is already false, that loop might never run at all. You have to ask yourself, Does this action have to happen at least once? Your answer tells you which loop to use.
Okay, so you've got your amazing design. Now, finally, you get to code, to translate that plan into a real programming language. But hold on, you are not done yet. Now comes the really crucial part, testing. This is how you prove your awesome logic actually works.
And we basically test in two ways. First, you have unit testing, where you check every little piece of your code all by itself. Then you have integration testing, which is where you make sure all those little pieces work together nicely as a team. The real mindset here is that you need to try and break your own code seriously. Good testing isn't about proving it works. It's about hunting down every single way it might fail.
And that brings us to the final, and I mean most critical section. Pay attention, because mastering these specific algorithms is what separates the A grades from the A-star grades. These are the tools you'll need for those high-mark questions that are pretty much guaranteed to be on your exam.
First, the fundamentals. You will almost certainly be asked to do one of these three things with a list of data. Totaling, which is just adding up a bunch of values. Counting, where you tally up how many items meet some rule, like students who passed. And finding the max or min value, like identifying the highest score in the class.
And now for the big two, searching and sorting. A linear search is simple. You're looking for one specific thing in a list, so you just check every item, one by one from the start until you find it. A bubble sort has a totally different goal. You want to put the entire list in order. You do this by repeatedly comparing two items next to each other and swapping them if they're in the wrong order.
Okay, let's actually see a bubble sort in action, step by step. Imagine the examiner hands you this messy, unsorted array. Your job is to sort it from smallest to largest. Let's see what happens on the very first pass.
And boom, after just one pass, look what happened. The algorithm shuffled things around by comparing pairs, and the single largest number in the whole list, 19, has literally bubbled up all the way to the end, right where it belongs. That spot is now locked in.
Now for pass 2. The algorithm completely ignores that 19 at the end and just does the exact same process on the rest of the numbers. After all the swaps, the next biggest number, 14, bubbles up to its correct spot. See the pattern? With every single pass, the sorted section on the right side of the array gets bigger by 1.
And this brings us to the final A-star level challenge. You know how to sort numbers. But what if you also had an array of student names that corresponds to those scores? When you swap two scores, what else do you have to do to make sure the right name stays with the right score? Think about that. Solving that kind of problem, keeping that data linked, that's what shows you're thinking at the highest level. Good luck.